In this video, we're going to talk about the time value of money, specifically focusing on the future value. The concept is quite simple, but very powerful and often used in actuarial science. And that is that we can move money through time. Money can travel backwards in time and money can travel forwards in time. Now, when we move money through time, we need to allow for interest that would have accumulated within the period. This sounds a little fuzzy, but it's actually quite simple. So let's focus with the most intuitive example, which is the future value of money or money traveling forward in time, also called the accumulated value. Suppose you have an investment of $1,000 and that your investment earns interest at 10% per year. What do we mean by money traveling forward in time? Now, it simply means that your money at the end of year one would be worth more than the initial investment because of the interest that you have earned. So in our specific example, the $1,000 that you've invested will earn interest at a rate of 10%. So at the end of the year, the money will be worth your original investment of 1,000 plus 10% of the money that you've invested. We can simplify that as $1,000 multiplied by 1.1. So at the end of the first year, your money has increased from $1,000 at time zero to $1,000 with 10% interest at time one. So the interest earned in the first year is just 10% of $1,000, which is $100. So your balance at the end of year one is just equal to 1,001. It's just equal to 1,100. 1,000 of this total is just your investment. So that's the money that you've invested. And $100 relates to the interest that you have earned during year one. In total, this is the 1,100, and we can rewrite this as 1,000 multiplied by 1.1. In order to calculate the value of your investment at the end of year two, means we have to add interest for another year. Most real-world problems that we encounter, both the interest that you've earned during the previous year, as well as the original investment, will earn interest in year two. So this means we can simply take the total amount that we have in our account at the end of year two, which is equal to 1,000 increased by the 10% interest we have earned, and then add another 10% interest to this amount. So some of the implied knowledge that we'll be using in your actuarial studies quite a bit is the laws of exponents. So if you recall that a number that is raised to a power simply means that you take the number and multiply it by itself 2 times. So when you're multiplying two numbers and the base is the same, so in our case, the base number is x, so it is the same, and it simply means that you can, it simply means that the answer will be the same base number, but the exponent will be the sum of the two exponents that are being multiplied. So in other words, x to the power 5. If you think about this in terms of what it actually means, it makes sense, right? Because x to the power 2 just means multiply x by itself twice. This instruction means multiply x by itself 3 times. So if you have these two instructions and you combine them, it simply means that you multiply the number x by itself 5 times. 2 times for the first instruction, and then another 3 times for the second instruction. So if you go back to this example, it means it is 1,000 multiplied by 1.1 to the power 2. This will be the value of your investment at the end of year 2. You should start to see a pattern here. Now, at the end of year 3, your money will be worth 1,000 times 1.1 to the power 3. So at the end of year 3, this is the value of our investment. So we have moved this $1,000 to time 1, time 2, and ultimately time 3. So we've moved it 3 years into the future. How do we get this future value? We just took the original investment of 1,000, we multiplied by 1 plus the interest rate to the power of the number of years. So if we want to generalize this, in general, let's suppose that we have an interest rate I, and suppose that N is the number of years that the money will be invested for. We can calculate the future value in this scenario by taking our original investment. Let's, instead of the 10,000, just make this P, and we say 1 plus the rate to the power the number of years for which the money will be invested. Now, more formally, this factor, 1 plus I to the power n, is known as the y, because we can use this factor. Why? Because we can multiply this factor by any investment. Doesn't matter what that may be, $1,000, maybe 10,000, maybe $1 million, and we can use this accumulation factor to move the money forward n years into the future. So we would know the value of this investment n years from today. Now, a final note is the type of interest that we've been talking about up until now is compound interest. And that is the scenario where interest earns interest. There's also another scenario that you need to be aware of called simple interest, where only the original sum invested earns interest. By far the most important type of interest is compound interest, and you'll encounter it 99% of the time in this course. Just be aware of this simple interest that exists.